Assalamualaikum warahmatullahi wabarakatuh. Good morning to everyone. My name is Muhammad Iqmal bin Muhammad Taib. I am a student at Faculty of Electrical and Electronic Engineering from Universiti Tun Hussein Malaysia. My project title is a pickup plant mechanism for vertical farming system that had been supervised by Dr. Noor Azizi bin Mahdi. What is vertical farming? Vertical farming is a method of growing plants by stacking the plants on the shelf. This method has been applied in the cities or urban areas like Korea, United States of America, and also in Malaysia at Selangor and Pulau Pinang. The company name is Babylon Vertical Farming, City Farm, and Urban Farm Technology. Why we use vertical farming? Due to the limited access to land for farming, this method is really suitable to overcome this issue, which is to ensure that the qualities and quantity of the food supply will be able to sustain in the future where human population is increased. There are some points that have been taken to overcome this issue. Firstly is too many manpower. This is because the farmer need to hire more worker to harvest the crop. Secondly is the lack of workspace. This is because the arrangement of the shaft is close together to get the more production. The third is the lack of safety in the workplace. The objective of this project is to develop the conceptual design and the prototype for the plant pickup mechanism. Second is to design a coding for controller system and construct the circuit for the plant pickup mechanism. The third is to analyze the prototype of the plant pickup mechanism, either is it working or not, and to troubleshoot the problem. For the methodology of the project, they have some controller components that we use for this project, which is firstly is AC to DC 12 volt power supply. Next is the Arduino Uno R3 with the CNC shield. The third is push button module, and fourth is DC fans. So for the mechanism, they are including with the screw slider linear table, and two stepper motor NEMA 70, and stepper motor mountain, and the four is tray holder for the plant pickup. This is the block diagram for the pickup plant mechanism. As we can see, this project get the power from the 12 volt power supply from Arduino Uno and CNC shield. CNC shield is an extender board that connect with the stepper motor pins and the A4988 stepper driver. This mechanism consists limit switch for both X and Y axis. The push button used in this mechanism is to control the home position, pick up position, and put down position. Now I will explain the flowchart of this project. Firstly, when the supply is get for the Arduino and CNC shield, the stepper motor for the X axis and Y axis will be on. So the motor will be on until it touch the limit switch for the X axis and Y axis. This is will be called as home condition, which is the initial position for the mechanism. So after that, the mechanism also have three buttons that we use. Firstly is home button. Home button will be back to the instruction first, which is to get the home condition. Okay. The second is the button for the pickup plant. So when button is on, the mobile arm will do the instruction, which is firstly is to the forward. After that is to lift up the plant tray. After that back to the home position, which is the one cycle complete for the plant, for the pickup plant. The third button is the put down the plant. This is when the tray at the holder, at the arm holder for the tray, the mechanism will going upward. After that is forward. to put the plant tray on the shelf. After that, it will be downward and back to the home position. So that is the cycle of the mechanism. This is the list of the component that we use for develop the prototype of the pickup plant mechanism. Firstly, we have the screw slider linear table. The table slider move in the linear condition that helped by the stepper motor. After that, Arduino Uno R3 is our main microcontroller. CNC shield is used as the extender for the A4988 driver stepper motor. A4988 driver stepper motor used to control the speed and the rotation of the stepper motor. So the stepper motor that we use is the NEMA 70, which is require 12 volt for the supply to operate, and we use the AC/DC power supply for 12 volt. After that, we have push button, 3 push button, which is one for the home, pick up plant and put down the plant. And lastly, we have the limit switch. Limit switch is used to stop for the home condition. So this is the list of the component that we use to develop the pickup plant mechanism. This is the software that I implement in this project, which is firstly is Arduino IDE software. Second is freezing software for the circuit, and the third is SolidWorks software for the design. So this is the schematic design for the system. In this, we can see that this is the Arduino Uno. I will connect to the power supply for the Arduino, and A4988 stepper motor driver. The driver will connect to the stepper motor. So we have the push limit switch in here and push button in this. So this is the complete circuit for the controller system. So this is the SolidWorks that used for the design, and also can use for the 3D printing. The design for the mechanism is like this. So we have the screw slider linear table, and then the stepper motor, and the stepper motor mount, and this is the tray holder arm. So 3D printing, I have print the stepper motor mount because the design is custom for the y-axis. So that's this the produce item that have been print using the 3D printing. This is the coding for the home position, pickup position, and put down position for pickup plant mechanism. The coding is using the Arduino IDE software as a platform to give the instruction to the Arduino Uno. This is the result when running this program. As the result for home position, the time taken to complete one phase position take time less than 8 seconds for x-axis, while the y-axis take less than 3 seconds. The longest position for the x-axis take time less than 23 seconds, while y-axis will take time less than 8 seconds. The pickup operation is the process when to take out the plant tray out from the shelf, while the put down operation is the process to put down the plant tray into the shelf. For the pickup operation will take time less than 2 minutes to pick up the plant tray out from the shelf. For the put down operation also will take time less than 2 minutes to put down the plant tray into the shelf. As the conclusion of this project, all the objectives had been successfully achieved. For the first is the plant pickup mechanism for the vertical farming system had successfully designed by using the SolidWorks software. Okay. For the next objective is the algorithm for controlling. The system has successfully developed. Furthermore, the coding has been verified on the hardware to ensure that it functions properly. The third objective is the prototype of the plant pickup mechanism has been successfully tested and demonstrated to analyze the output of the mechanism. So that's all for me for the pickup plant mechanism for the vertical farming. Thank you.